Hey, welcome back to your favorite trigonometry class. We're going to continue with these inverse trig functions by defining the inverse secant, cosecant, cotangent function first, okay? So with the arc secant, so the inverse of the secant, this would be true if and only if x equals the secant of y, where we're between 0 and pi. So similar to the cosine, we're going to be between 0 and pi. For the arc cosecant, and by the way, this is from most textbooks, traditionally speaking. There are other definitions of the arc secant and arc cosecant. With the arc cosecant, similar to the sine, we're restricting between negative pi halves. Arc cotangent, though, 0 to pi. Let's do some examples here and kind of get working through these here. So the arc secant of 1, we're going to set that equal to theta. Now our theta, kind of like the arc cosine, we have this theta being between 0 and pi. Okay. What we're going to do is we're going to say, well, if the arc secant of 1 equals theta, then we know that the secant of theta equals 1. Again, theta between 0 and pi there. And by the way, theta cannot be pi halves, right? It cannot be pi halves because we get the inverse of the secant there. It's undefined. So now let's think about this for a minute. If the secant of theta equals 1, that means 1 over the cosine of theta equals 1. I multiply both sides by cosine, right? This side by cosine, side by cosine, then I divide by that 1 right there, divide by that 1. So we got cosine of theta is 1. And now we're just answering the question, well, the cosine of what? Again, we're looking between 0 and pi. Right, the cosine of what is 1? Between 0 and pi, we say, well, it's right there. So we're actually at 0 radians. We know the cosine of 0 is 1. So theta must be 0. So we just found theta. Hence, the arc secant of 1, which is theta, is 0. Let's do the arc cosecant of 2 now. So be the arc cosecant of 2, we're going to set equal theta. That means the cosecant of theta equals 2. And theta, similar to the arc sine, we're between pi halves and negative pi halves, except we're not defined. Theta can't be 0. We're not defined there. Okay. Well, if the cosecant of theta equals 2, then 1 over the sine of theta equals 2. Multiply both sides by the sine of theta. So 2 sine of theta equals 1. Divide by that 2. So sine of theta equals a half. Again, we're looking, this is between negative pi halves and pi halves. All right, so we're looking in negative pi halves and pi halves. We're just looking for where do we have a sine of theta that is a half. And we say, well, we know it's right there. We have a y value that's a half. That's a pi 6. We know the sine of pi 6 is a half. So theta must be pi 6. So the arc cosecant of 2, which is theta, must be pi 6. The arc cosecant of 2 must be pi 6, okay? Because, and again, we're approaching it this way because most calculators, let me pull up Desmos, the scientific calculator. They'll have the arc sine, arc cosine, arc tangent. You might be able to look in your catalog for the other ones. But that's why you're gonna approach it. You can't just punch in. Can't just punch in. Whoops. Can't just punch that in, right, on your calculator. Again, depending on the calculator. Let's do the arc cotangent of negative root 3 now. So the arc cotangent, negative root 3, we're going to set equal theta. So that means the cotangent of theta equals negative root 3. And I look at my definition, I say, well, theta's got to be between 0 and pi on this thing. So that means we're looking for a ratio, right? A cosine over a sine that gives me negative root 3. Right? So I'm looking, I say, well, cosine over sine somewhere in here, right? Where the cosine over the sine would be the cosine over the sine, the cotangent is negative square root of 3. I say, well, is it this one? Is it 2 pi thirds? Because again, I want it to be negative, so I got to have a negative x and a positive y, right? That one's got to be negative, that one's got to be positive. If I would have picked something in here, that'd be positive over positive. It wouldn't give me the negative that I need, so I know it's got to be out here somewhere. I say, well, is it 2 pi thirds? That cosine's negative a half. The sine's root 3 over 2. Now that can't be right, because when I simplify that, it's negative 1 over root 3. So it's got to be the 5 pi 6. The cosine of 5 pi 6 over the sine of 5 pi 6 is negative root 3 over 2 over 1/2, which is, there it is, negative root 3 over 1 when I simplify that. That's what we're looking for, negative root 3. So 5 pi 6, let me go back to my page here, not that one, there we go. So 5 pi 6 over sine 5 pi 6, and that gave us the negative root 3 over 2 over 1/2, which is negative root 3. So theta's got to be that 5 pi 6. So theta's 5 pi 6. So the arc cotangent of negative root 3, which is equal to theta, is 5. Oops, gosh dang, why is it doing that? 5 pi 6 is 5 pi 6. Okay. All right, let's keep going some more here. Now we're going to apply using a calculator for these. So the arc secant of 8 inverse of the secant. So again, I'm going to set that equal to theta, which means that the secant of theta equals 8, where theta, similar to the arc cosine, we're going to be between 0 and pi. Can't be pi halves, by the way. And then we say, well, again, I don't have an arc secant button. This is the whole reason I'm doing it this way. I know the secant's 1 over cosine. So 1 over cosine equals 8. Multiply both sides by cosine. Divide by 8. So cosine theta equals 1/8. And then right there, that's where I can take the arc cosine on both sides. And I say, oh, now I take the arc cosine, the arc cosine. So theta equals the arc cosine of 1/8. And then I punch that in to my calculator. So I can punch it in here. Make sure you're in radians. You get 1.445468496. So to 2 decimal places, approximately 1.4. You know, that's going to bump that up right to 5. Around that thing. Okay? 1.45. See the next one there. Arc cosecant of negative 2. Set equal theta. Set cosecant of theta then must be negative 2, where our theta between negative pi halves, theta cannot be 0 either. So the cosecant is 1 over the sine. So 1 over sine theta is negative 2. which means 1 equals negative 2 sine theta, which means sine theta, once I divide both sides by negative 2, is negative 1/2. So if the sine of theta is negative 1/2, and now we run the arc sine on both sides, so we can use that arc sine button on our calculator. Theta equals the arc sine of negative 1/2. And then we punch in the arc sine negative 1/2. Let's see, we get negative 0.5235987756. So approximately negative 0.52 for the arc cosecant of negative 2. And that's kind of how we're approaching these. Let's keep going here. The arc cotangent negative of 1/5. So that means the cotangent theta is 1/5. Now this is a little different. So I got to kind of really think about this one for just a second. So if the cotangent theta is 1/5, now remember cotangent's cosine over sine, right? We're looking between 0 and pi. So are we in quadrant 1 or quadrant 2? Well, if it's a positive 1/5, the x has got to be positive and the sine's got to be positive to keep positive. So I'm in quadrant 1. So what I'm going to do is I'm going to draw this thing, this angle, into quadrant 1. Here's my theta angle, okay? And I know that the cotangent, right, if you remember SOHCAHTOA, sine is opposite over hypotenuse, your right side triangle trig, cosine adjacent over hypotenuse, tangent is the opposite over adjacent, right? Oh heck, another hour of algebra, forget that. So the tangent, the cotangent, I'm sorry, would be adjacent over opposite. So that would be adjacent over opposite. Since the tangent's opposite over adjacent, that'd be adjacent. The next to angle, 5 would be the opposite angle. And then what we're going to do is, so here's step 1, okay? Now step 2 is we're going to solve for our hypotenuse right here. I'm going to call it C. So 1 squared plus 5 squared equals C squared. So 26 is C squared. C is plus or minus root 26. So take the positive root 26 there. So square root of 26 is our hypotenuse. And then what we do here is we have no arc cotangent on our scientific calculator. Okay, so here's where you got to think. So we're going to find the cosine of theta, and this is the whole reason I drew this. So now we're going to find the cosine of theta, and that's because the arc cosine has the same range as the arc cotangent, the inverse of the cotangent, except of course where it's undefined. So I then say, all right, the reason I drew this so I could use the cosine and make this solvable. So the cosine of theta. Now remember, the cosine of theta is adjacent over hypotenuse. So I just say, who's the adjacent side? Here's my adjacent side, the next two side. Adjacent, here's my hypotenuse. So 1 over root 26. And then when I run the arc cosine on both sides, so the arc cosine of the cosine of theta, arc cosine 1 over root 26. Theta is the arc cosine of 1 over root 26, which is the same, this is the exact same thing as the arc cotangent of 1/5. But this I can punch into my calculator. So I punch in the arc cosine of 1 over root 26. Let me punch that in. 1.373400767. Okay, so 1.37. Okay, and that's the arc cotangent 1/5. That's your theta. 1.37. Let's do one more like that. The arc cotangent negative a half. So D. The arc cotangent negative a half. Set that equal theta. That means the cotangent of theta is negative 1/2. In other words, the cosine over the sine theta negative 1/2. And this is where your theta, if you remember, is less than pi greater than 0. Okay. So, excuse me. Cosine over sine is negative, right? So, and the question is, am I between, if I'm looking between quadrant 1 and 2, because I'm between 0 and pi here, quadrant 1 and 2, that means my sine's always positive in 1 and 2. So my cosine's got to be negative. So I got to be in quadrant 2. So I'm going to draw this thing into quadrant 2. Okay, there's my theta rotation. Here's theta prime, my reference angle. Okay, so cosine over sine. So that means since my tangent's opposite over adjacent, that means this is adjacent. All right, cotangent, if my, this is adjacent, let me get it in a different color. This is my adjacent, that's my opposite. Okay, so I'm looking at my reference angle theta prime. Here's my adjacent to that, next to it. Here's my opposite. We got to solve for our hypotenuse C. So now our step 2 here. This was step 1. Step 2, solve for the hypotenuse. A squared plus B squared equals C squared. I know that's a distance, but I call it -1 to make sure that my cosine always stays positive. Well, plus B squared, so 2 squared, C squared, so C equals the square root of 5. Punch it in right there, throw it in there for your hypotenuse. So you got square root of 5. And now here's where we say again, we say, well, because we're going to find the cosine of theta because the arc cosine has the same range as the arc cotangent, except where it's undefined. So the cosine of theta, oh heck, another hour, adjacent over hypotenuse, right? So katoa, if you remember it that way, is, so cosine of theta is adjacent. Here's my adjacent. Here's my hypotenuse. So -1 over root 5 cosine of theta. So that means once I take the arc cosine of both sides, this is the same thing as the arc cotangent of -1/2. So this will give you 2.03443936. 2.03. All right, I'm going to stop right there and do the next one. Just a second.